parallel connections. Let's talk about the connection which is very important for all of us, as all the appliances in our houses and schools are connected in such a way. So, let's take 3 bulbs and connect them in parallel to the battery terminals as shown here. If you take a voltmeter and measure the voltage across each bulb, you'll find that all the voltages are equal to the potential difference across the battery terminal V. Also, just like the traffic gets divided when there are parallel roads between any 2 destinations, the current in this case also gets divided between the 3 bulbs. You can also measure this using ammeters. You'll find that the total current in the circuit will be divided across the 3 bulbs. Therefore, I will be equal to I1 plus I2 plus I3. If we replace the bulbs with resistors R1, R2 and R3, then according to Ohm's law we have I1 is equal to V by R1, I2 is equal to V by R2 and I3 is equal to V by R3. Again, if we want to replace the complete resistors with an equivalent resistance, a current I and the same battery of potential difference V, we get by Ohm's law that I is equal to V by R equivalent. Therefore, we have already seen that I is equal to I1 plus I2 plus R3, which implies that V by R equivalent will be equal to V by R1 plus V by R2 plus V by R3, or 1 by R equivalent will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. So, therefore, in a parallel circuit, the reciprocal of an equivalent resistance is equal to the sum of the reciprocals of the individual resistors. The number of resistors doesn't matter. It might be 1, 3, 5, 10. If all of them are connected in series, add all of them, and if they are connected in parallel, add the reciprocals. As you can see, in a parallel circuit, even if one of the bulbs breaks down, the total current just gets divided among the other bulbs. Thus, in our home, since all appliances are connected in parallel, even if one tube light fuses, all the appliances continue their functioning. Let us now look at a very interesting problem which consists of both series and parallel resistors. As you can see, 4 ohms and the 12 ohms are connected in parallel with a 7 ohm resistor in series. If we are to find an equivalent resistance for this entire circuit, we will need to look at each part of the circuit separately. It is best advised to first find the equivalent resistance of all the parallel resistances. So, in this circuit, the equivalent resistance R equivalent 1 of the 4 and 12 ohm resistors is 1 by R equivalent 1 is equal to 1 by 4 plus 1 by 12, which implies the R equivalent 1 is equal to 3 ohms. This parallel resistors can thus be replaced by an equivalent resistance of 3 ohm. This 3 ohm resistor is now in series with a 7 ohm resistor. Therefore, the total equivalent resistor of the complete circuit becomes 7 plus 3, which is equal to 10 ohm. Thus, this entire circuit is equivalent to this circuit. So friends, in this video we learned about parallel connection and how to find the equivalent resistance when all the resistors are connected in parallel. Till next time, happy learning!